If we were writing the future value graphing program from scratch, we might start by breaking it down into smaller problems. The first smaller problem might be creating a window and labeling the axes. Because we'll need to use the GraphWin window later for drawing the rectangles, we need the function to return the GraphWin object. The second problem could be drawing a rectangle for a given year. This is the same function we wrote earlier. And then we could write our main function that uses these two functions. Many programmers write out the steps of the main function, either in their head if it's short, or on paper if it's too long for them to keep track of. The next step is to look at the code that may be used multiple places and write a function for it so we can avoid repeating the code. We should also think about which of these steps are still too complex to write all at once and break those down into more functions. Some programmers write the main functions first and then begin writing each function, while others write the individual functions first and then write the main function. Chapter 9 of the book discusses these approaches in more detail, and we'll discuss them when we get to that chapter. I'm going to discuss one other concept that is not in the book. Recent versions of Python added a feature called type annotations. The book was nearly complete before these features were added. Type annotations allow you to indicate the type that each formal parameter should be and what type the function returns. Using them is optional in Python and not required, but does allow the inspect feature of PyCharm to help you find more mistakes. Python supports a concept called duck typing, so specifying the exact type a function expects can be limiting, but we'll ignore that concept for now. Before adding the type annotations, let's make a mistake and send the parameters to the drawBar function in the wrong order. We'll put the win parameter last. If we run the inspect option now using Shift-Alt-I, it does not find any mistakes. Let's add the type annotations now. The syntax for adding a type annotation for parameters is to put a colon and the name of the type after a formal parameter. We'll do this for the drawBar function. The syntax to specify the return value for a function is a minus sign and then the greater than sign forming an arrow, and then the type that the function returns. This is placed after the parentheses and before the colon. We'll do that for the createLabelledWindow function. Now if we use the inspect option, we can see that it tells us we've sent the wrong types to the drawBar function. If we run it, it crashes as it would even without the type annotations, since when we are creating point objects we must use numbers, but in this case one of the parameters is a GraphWin instead of a number. From this we could probably find our mistake, but the inspect option with the type annotations makes it easier to see exactly what we did wrong. So while adding type annotations is extra work, it does make it easier to find mistakes and also makes it more clear what type each parameter should be for someone who's going to use the function. Without type annotations, we should add comments indicating the type of each parameter. We'll learn about adding documentation strings in a later chapter, showing a good way to document both the types of the parameters and what a function does.